All right, hello everyone. Welcome. This is KNative bringing serverless to Kubernetes. My name is Bret McGowen. I'm a developer advocate for serverless at Google on the Google Cloud Platform team. You can follow me on Twitter there at @BretMCG. So a couple things that you should know about me. I love serverless. The other, you might guess, maybe from this giant graphic in the background, I live in New York City. However, I have to say, even though I live in New York, I'm from Texas. There we go, much better. So howdy and welcome. A little bit of a word of warning. I'm going to use some language that you're not supposed to use when you're talking about serverless. So the serverless community doesn't like to use words like containers, Kubernetes, infrastructure. We definitely don't use the word offline, cluster of virtual machines. These are all concepts that are off limits or sort of forbidden in the serverless world. But it's pretty integral to running serverless workloads in your data center or in multiple clouds on top of Kubernetes. So if you're offended by these words, I won't be mad if you want to step out, because we're going to talk a lot about them. So first, at a high level, just to recap, so what does it mean to be serverless? There's no real official definition. This is my very high-level take. So it is invisible infrastructure. So you just worry about your code, and the number of servers you need scales up and down automatically without you having to worry about it. And similarly, scales down to 0, which means if your code isn't actually running, you're not actually paying for it, or there's no idle process that's sort of sitting and waiting for something to happen. So that's at a high level. If we dig in a little bit deeper into what does it mean to be serverless, there's sort of two slices, two ways you can look at it. There's the operational model. This is like the ops perspective. So that's like the server part, who's managing the servers, who's installing security patches, who's installing OS updates, who's making sure all the libraries are the same version across multiple nodes and servers, who's handling security, and sort of the financial part of it. And that's the operational side. And what we're going to focus on today, though, is the developer side. So from the developer's perspective, how can I get this nice serverless, code-focused, service-based, event-driven programming model, regardless of who's actually running the ops, whether your ops is being run by Google or Microsoft or Amazon or someone in your own team, or maybe you. As a developer, you want to get this nice serverless developer experience. We just write the code and deploy it. So to that end, we're going to kind of walk across the serverless spectrum here. So going from left to right, we have sort of hosted functions as a service. So these are your Google Cloud functions, your Azure functions, your AWS Lambdas. These are things that someone in the cloud, your cloud provider, is managing all the infrastructure for you, not even someone in your own company. As we come over a little bit, we'll talk just a bit about serverless containers. So this is if you want to break outside the nice developer experience and maybe the limited set of runtimes that your cloud provider has, you can bring containers and make those serverless. And then continuing across the spectrum, as we have to do more and more sort of operational work, we're going to talk about serverless anywhere, so Knative on Kubernetes. And that's where we'll spend most of our time today talking about. And then kind of the other end of the spectrum is just if you're deploying directly to Kubernetes, it's not a very serverless experience. You have to be very aware of Kubernetes services and connecting them and how they all work together. So first, hosted functions as a service. So these are your Google Cloud functions, for example. Easiest developer experience, you just write some code and deploy it, and that's it. No one even in your company has to worry about the infrastructure. But again, along with that is limited runtime options. So for example, Google Cloud Functions only supported Node.js until earlier this year. Now we support Node and Python. But if you want to do something like Rust or COBOL for some horrible reason, we probably will never support COBOL directly in Google Cloud Functions. But if you do use one of the runtimes we support, it's a great experience. So let's do a quick demo. This isn't really going to be the focus of the talk, but I just want to sort of set the stage for, as a developer, what is it like to write serverless code and have it deploy and go into production? So here I have, all right, so I have an empty directory here. We're going to create a hello world, but because I'm from Texas, we're not going to do hello, we're going to do howdy. I'm going to do npm init. It's Node, I know, I'm sorry, but just bear with me. So npm init just sort of creates a new npm package, new Node package called howdy. Sounds good, version 1, description, test command, echo all tests passed. Git repository, I'll take credit for that. And we'll open source it under the Apache 2.0 license. Yes, looks good. Incidentally, so now if I want to run tests, so npm test, look at this, all tests pass every single time. That's how you get 100% success in your tests. So now let's actually write the app. So I have index.js. Let me open it up here in my editor. All right, so this is literally a hello world application. Not a lot to it. If you don't know Node, just briefly, here we have this is an HTTP function, so we have a request and a response. Let me actually go ahead and deploy that so that it can be deploying while I talk. gcloud functions deploy howdy trigger HTTP. So this particular example using Google Cloud Functions, that's what I know. I work for Google, but sort of similar functionality for Azure and AWS as well. So request response, we're going to look in the query string. If I'm given a location, use that and say howdy that location. Otherwise, we'll default to Belgium. Return directly over HTTP, status code 200, and send howdy. But you'll notice we don't have to specify how many machines I need, where's the load balancer. I don't even have to specify a URL. Like a fully qualified domain is automatically provisioned, SSL cert put on top of that, so I can do HTTPS right away with literally just 4 lines of code, or 3. All right, so let's find our URL. It is here. So let me click this, and so there's our serverless function, hello, howdy Belgium, and I can change this location to New York City, or Narnia, or whatever. All right, so that was super easy, right? So again, just to set the stage, this is the serverless developer experience we want to try and bring to your developers wherever their code is running. And currently there are 2 major challenges. There's a bunch, but here are 2 challenges in serverless. One is dependencies, and I alluded to it before. If I want to use a language that's not supported by my cloud provider, I'm often out of luck. Or if I have some native module, if I want to do some like 3D rendering or something, you have to inject that into the cloud provider if they even support it at all. So that can be a huge pain. And the next is multi-cloud. If I want to run my serverless functions on multiple clouds, or I want to run them in my data center or on my workstation, it's pretty difficult to do that. So these are the 2 challenges we'll talk about today. So the first, containers. This is how we're going to address bringing your custom runtime. So for example, here we're going to install Blender, which is an open source 3D rendering platform. Who here is like writing code in containers? Don't need to, okay. So just very briefly, for our purposes here, we're just going to think about containers as just a packaging format and a declarative way of saying, I want these particular libraries or these runtimes available in my function. So again, Blender is a 3D rendering library. We'll probably never have Blender just built into Google Cloud Functions available to everyone because you kind of want to keep those images nice and lean. But if you want to do that, here's a Python app. It installs Blender and then installs Flask, which is the web framework for Python, or a web framework for Python. All right, so that is kind of set up serverless container. So the idea is instead of just taking the code, we now have code and this like associated Docker file to describe the runtime environment in which it exists. Let's do a quick demo of that. All right. So we're going to upgrade our howdy function. So instead of howdy, it's going to be howdy 3D. All right, and let's edit our Python file here. I'm not going to go into the details here, but already you can see there's a little bit more we need to do as a developer if we're doing a container versus just functions as a service. For example, we have to explicitly set a route. And that might be good or bad depending on your use case, because I could say here is my route, my cool route is here. But still, you have to specify that. Whereas something like Cloud Functions, you just automatically get that. Other than that, this is a pretty typical Flask app for Python. Again, it uses the Blender library to do some 3D rendering. And so the main difference is we have now not just our code, but we also have this Docker file. It's the same Docker file I just had on screen, installs Blender, and then installs Flask, and then starts your application. So let's actually, let me switch over here. So we would like to actually gcloud alpha serverless. We're going to deploy this as a function. I'm going to call it howdy 3D. And I've already uploaded this Docker image ahead of time, just so you don't have to watch me upload and build Docker images in the cloud. Howdy 3D. Very secret is the name of my project because until recently, the ability to deploy containers on Google Cloud Functions was not public. So this was sort of to remind me, don't leak this, but it's all right now. But it's doing the same thing. So it's going to create a container that is going to scale in the background. It'll be able to tie it to different cloud events, so things like an HTTP request, a Google Cloud Pub Sub event, or a file upload, and so forth. All right. Similarly, it's going to create for me a URL. This fun-looking URL here. Which let me go ahead and run that. And that was a little bit too fast. I think that may have been cached. So let's do another location. So location equals Belgium. And location equals Devoxx 2018. All right, there we go. This one's actually rendering. I think it was caching those others. Doesn't go quite that fast. But again, the point here is we're doing 3D rendering in a function. So sort of whatever your specific runtime needs are, library needs, as long as it can be expressed in a Docker file, we could take it and we could, oh no, I'm missing an X. We could take it and we can run it the same way we do Cloud Functions. Create a URL for you, do load balancing, handle networking, and all that. Which brings us to the second challenge in serverless. So dependencies, we can handle with Docker containers. Multi-cloud, how do we actually take our functions and run it in different clouds, in our data center, in different environments in the same manner? So here we're going to talk a lot about KNative as sort of the crucial part of this. And there's a lot of reasons you might want to run KNative on top of Kubernetes, which we'll get into in a second. But first, so who's running Kubernetes? Who's familiar with Kubernetes? Okay. Who's not familiar with Kubernetes? Okay, and that's fine. I will do like kind of a high-level overview of what Kubernetes is, so don't get too lost. So we talked a bit about containers. Think of it as a packaging mechanism for your app. You can define dependencies and all that. But now, once you have a container or a bunch of containers, you need a way to run them. Like what machines do they go on? If one falls down, who restarts it? And Kubernetes is a great solution for that. In fact, it has quickly become the standard, the de facto way of running your containers. And it's so popular that before Knative, there were already over 13 different functions as a service, sort of serverless tools, built on top of Kubernetes. So Kubernetes is clearly a good foundation, but there's a lot of overlap between those functions, between those different projects. A lot of people were solving the same problems over and over. But why is Kubernetes a good foundation for doing functions as a service? There's a few things that it does well, right? So if your container dies, automatically restarts it. If your container is sick or hung, your process is frozen, it'll reboot it. If the server itself is dead, it'll schedule your container onto another node. So it gives you the ability to have a highly available system that's really resilient. So that's a good foundation for building your serverless platform as a service. The problem is Kubernetes is not easy. If those of you all who raised your hand probably can attest to this. It's great, it works really well, but there's a lot of knobs and there's a lot of knowledge you have to have about Kubernetes. In fact, if you are running your own production Kubernetes cluster for your organization, for your company, you probably have someone whose full-time job it is to manage this. So to address that, there are tools like Google Kubernetes Engine, and there are similar ones for Azure and AWS, that take the maintenance of the actual Kubernetes cluster away from you, so that as a developer, or as an application team, you just have to worry about fitting your application into Kubernetes. So setting up, what does the service look like? What does service discovery look like? How many copies of my application do I need? How many instances, and so forth. So it takes the actual maintenance of Kubernetes itself away. So it does things like it can auto-upgrade your Kubernetes clusters as you go on. If your actual VM, if your nodes are unhealthy, it can pull them out. It can scale the actual VMs and nodes up and down. But there's still a lot of work left to be done. And the idea is that Kubernetes isn't actually for developers. That has not stopped a lot of us from trying to use it directly as developers. It's really intended for operators, right? It solves the problems that operators want to worry about. Excuse me. But it is a good foundation for building a platform as a service on top of it. Because if you're writing for Kubernetes, there's still a lot of stuff you have to worry about on the left. But as a developer, all I really want to do is write code. The very first example with my 4 lines of Node.js, that's all I want to worry about. So if it takes a lot of work to run Kubernetes, if it's maybe a full-time job to keep it up and running, why bother? What are some of the reasons? Why wouldn't I use just that functions as a service in the beginning? And there are a few. One is reduce lock-in. So if you're really concerned about having your code run the same on Google Cloud, as on Azure, as on your data center, Kubernetes is a great way to accomplish that. Maybe you have specific performance needs, or you have custom hardware. So if you're doing machine learning, and you have GPUs or TPUs or customized hardware for your application, most serverless functions as a service, your Google Cloud functions of the world, aren't going to support that hardware, or at least not anytime soon. So if you have that hardware in your data center and you want to take advantage of it, Kubernetes will let you do that. Similarly, if you just have existing infrastructure, right? I already have a warehouse full of servers or a closet full of servers, and we don't want to just throw it away to move to the cloud. Maybe we will over the course of the next couple of years, but there's a huge sunk cost, so we want to take advantage of the money we've already spent on our hardware. Similarly, offline, a great example that we love to talk about is oil rigs, right? So these are oil tankers out in the middle of the ocean, and they're drilling for oil, and they're generating terabytes of data, just tons and tons and tons of data. And so you want to do processing on it. Well, you can't say, well, just upload all of that data to the cloud, because they're really in the middle of nowhere, and they're basically connected to the internet with a 2G or a 3G modem. You literally cannot upload terabytes of data to the cloud. It would just be a colossal cost. So you want to actually run some clusters to do data processing, say on board the ship or on board the tanker. And it would be nice if you have the same developer experience to deploy on-premise to your offline application as you do into the cloud. And so similarly, there's a bunch of other reasons why you might want to use Kubernetes. So there are a lot of legitimate use cases to why maybe you can't just use the hosted functions as a service. That's the easiest, right? Because you just write code, and literally no one in your organization has to worry about it. But it's not always possible. So what would it take to build a serverless framework on top of Kubernetes? So assuming Kubernetes at the bottom, for all the great, good Kubernetes resiliency reasons we just described, there's some things in the middle that every platform as a service has to do, every functions as a service has to do. Those 13 plus I talked about, they all solved these problems separately. So things like build. How do I go from source code on my workstation to a built Docker container that can be run and scheduled by Kubernetes? Autoscaling. So Kubernetes potentially has the ability to scale your cluster up and down, and maybe even your pods up and down, but what about scaling to 0? So scaling and how the scaling works is a problem that all of these functions as a service platforms need to solve. Invoker. So the difference between, in the Python app, I actually imported Flask specifically and mapped the URL routes, and so you can think of this sort of an invoker that takes my specific rendering function and wraps it in a web framework. So do you have that standardized, where you can just give a function and you don't have to wrap it in a web framework? Routing, a request comes in through some URL. How do I map that to my function? Who does that? What's the responsibility? Can I do things like blue-green deployments or canaries? How do I bind to events? How do I do observability? Where do my logs go? Who's collecting the logs? How do I do things like tracing the code and seeing where my performance problems are? So again, these are all things that everyone who's building a serverless platform has solved separately. And it's only until you get to this top level that these different products start to differentiate themselves. So developer experience. Maybe one is hyper-optimized for Node.js, or maybe one is super optimized for your particular corporate application server. And if they're all solving them the same, that means we are spending time on things that don't give us a unique platform for our developers. We have a lot of duplication of effort. So what does it take to get in the middle layer? If I'm going to write my own function as a service on top of Kubernetes, this is a simplification, obviously, there are a few things that I need to do. So one of the tenets of serverless is when it's not actually running, your code goes to sleep, or all those resources go to sleep. But as soon as a relevant request comes in, something's got to wake up those requests, spin up an instance, load your runtime, load your dependencies, and do all that. So I need to do that. I need to handle scaling. How customizable is it? Does it scale up and does it scale back down to 0? Again, the very first developer experience was just writing a function and not wrapping it in a web framework. So I might need something to take my function and wrap it into your web framework. How do I collect metrics? How do I do revisions? Do I roll forward? How can I roll back? Again, canaries, blue-green deployments. And then eventing. So these are all problems in that sort of middle layer that everyone needs to solve to get a functions as a service platform running on top of Kubernetes. And that is where Knative was born. So the idea here was that we can solve kind of all those problems generally in a Kubernetes native way so that we don't have to keep resolving them at the top layer. It's an open source project. It's on GitHub, so github.com/knative. It didn't just come out of Google. We had a lot of super important partners that did a ton of work to help Knative get built. So folks like Red Hat and Pivotal and IBM and SAP. If you check on GitHub, you can see their contributions. So it really is a broad effort to start to standardize on top of Knative. In fact, folks like IBM and some of the open source functions as a service have started to rebase their existing platforms on top of Knative, so we can kind of solve all this routing and event binding for once and get one time, and then spend our effort on creating better developer experiences. So here's the KNative stack. It looks pretty similar to the hypothetical stack we just saw with Kubernetes at the bottom and these primitives in the middle. So right now we have 3 primitives. There's build, so again, taking your source code and turning it into a runnable container. Serving, as a request comes in, how do I route it? Where does it go? What version of your code does it go to? Events, so binding your code to events as they happen. And then we have the products level at the top. So these are things like Pivotal has a RIF function platform, Red Hat Cloud Functions, IBM Cloud Functions is rebasing on top of Knative, and then SAP Kima, which I'll talk about in a second. So just to kind of clarify, what is Knative? It's open source, it's a set of building blocks, and it's an abstraction on top of Kubernetes. If you're familiar with Kubernetes, there's a concept of custom resource definitions. So Kubernetes has these built-in concepts like pods and services and deployments. By using custom resource definitions, Knative introduces new ideas that can be managed with the same tools that you use to manage Kubernetes. But to be clear, what Knative is not, it's not a product per se, and it's not like sort of a Google product. And it's also not really designed to be directly used by developers. So you don't deploy to Knative directly. You can. You also could just deploy to Kubernetes directly, but I wouldn't recommend it. So there's no CLI. There is actually, I'll put a link up in a second. One of the guys from Pivotal created a CLI around Knative, so you actually could just use it just with this CLI. It's actually pretty cool. But there's no official CLI. You just use the kubectl, use the standard Kubernetes command line. So what do you do with it? Who are you? If you're a developer, you can deploy directly to it, but probably you should use one of those things like RIF or Cloud Functions, IBM Cloud Functions that runs on top of it. If you're an operator, this lets you give that serverless developer experience to your developers. And if you're actually building your own platform, you can use it to create your own functions as a service within your platform. So here, graphically, just to say what this looks like, if you're a developer, you can deploy to one of these top-level products that are already created, or if your organization is building one and you want a serverless developer experience for your developers, they can deploy to that, and it all sits on top of Knative and Kubernetes. So an example of one of these custom platforms is SAP Kima. So SAP obviously is not, you can't just like go write a Lambda function and have it run and integrate with SAP. It's its own sort of closed ecosystem. But SAP wanted to give SAP developers a serverless developer experience. So they built a product, also open source, called SAP Kima on top of Knative. So now if you're an SAP developer, you can write serverless functions just like you were deploying to Azure Functions or Google Cloud Functions. So that's the idea behind Knative, right? Is it gets you really close to that, and then just whatever is unique about your particular platform or your particular use case, that's where you can focus on. All right, let's do a quick demo of deploying to Knative so you can see what it looks like. I'm going to use the same 3D rendering example I used a second ago. So this is the same Docker file. This is the same Python file. But there's one new file here. This is a service, Howdy service file. So this is going to define a Knative service, and I'll explain in a second sort of some of the concepts in Knative and how they tie together. So it's a service. I'm going to name it Howdy3D, and then I'm going to point to. I already deployed the image, so it's going to pull this image, and then I have a couple of parameters I'm going to inject as environment variables. So in location, Belgium, and then scene, basic. Now let me go ahead and apply that cube. So again, I'm going to use just kubectl, which is just the normal Kubernetes command line. Oops, apply. I guess one thing I'm not actually demoing, I did ahead of time, was installing Knative on top of Kubernetes. It's not a super complicated process. There's sort of like a few scripts that you can download and run to go on top of it. It's not really like it's not quite a one-click install yet, but it's getting close. So let's create this as a service. So again, it's going to take this existing application and deploy it into my Kubernetes cluster. Hopefully. Uh-oh. Come on, am I frozen here? Oh, there it goes. Cool. All right, so it created this Howdy3D service. Let me see what the URL is. I'll say kubectl describe K service, so it's a Knative service called Howdy3D. And again, if you're used to using Kubernetes, you'll recognize things like kubectl apply and kubectl describe. So I do describe, and you can see here is the URL it gave me. I set up earlier this cluster to go onto bretmcglabs.com. So it's going to automatically create this URL. And let me paste it. And hopefully it will load. All right, so Belgium, and similarly, oh, this is a difference. Let me say scene. So we have the same 3D rendering as before. So there you go, Belgium. So same service. I didn't change the app at all. All I did was add the service descriptor file so that Knative knows how to schedule it. So again, you can start to see, like, as a developer, do I really want to muck with this service file? Maybe, maybe not. But it's a really big opportunity for folks to add on top of that a nice utility to do that for you. In case you're wondering, the naming scheme, it's so the name of your service, so in this case, Howdy3D, the name of your route, and then this default is the namespace. So there's a concept of namespaces in Kubernetes. I don't know why it's not highlighting. There we go. Default. And so in here, I say namespace default. So it'll say name of the service dot namespace dot whatever your domain is. All right. So that was deploying. So now let's dive in a little bit deeper into some actual principles and actual concepts of Knative, specifically around Knative serving. So again, this is a request comes in this case, over HTTP. How do I map that to my code? So why is Knative serving useful? It has some things built in. So just the HTTP routing is built in. Traffic splitting is built in. It integrates sort of nicely with the rest of Kubernetes and Istio and all the other objects. And it's pluggable. So if you want to have your own custom logger or your own custom way of handling metrics, you can do that. You can drop that in. Or out of the box, it includes tools like Prometheus and Grafana to capture a lot of that data. All right. So I alluded to the concept of a service in Knative. So a service you can think of as so in a serverless world, this is like your function, right? This is like my application. This is my unit of scale and my unit of serving and requests. So service, here is the YAML. Again, you point it to a Docker image, which is published somewhere, and you can optionally inject some environment variables. But let's dig a little bit deeper. So a service actually wraps a couple of things, one of which is configuration. So if you're familiar with 12-factor apps or just sort of modern best practices for apps anyway, which is you keep your code separate from your configuration. And that way, you can take your same code and deploy it to production, or to staging, or to dev, or to test, and all you have to do is swap out the configuration. So you would take your configuration as a separate object, stamp it with the code, and together, those two make up a revision. So in Knative, there's this concept of revision, and it is what your code and configuration together look like. And that's so you roll forward and roll back at the same time. And you don't accidentally roll forward to a new configuration, but keep the old version of the code, or maybe roll back your code, but your configuration is still the new version, right? So it keeps those locked. So it's much more tied together as you move forward. And then there's the concept of a route. So a route is, as you might expect, so a request comes in via HTTP. Like, how does it actually? What is that word? What is the name? How does it actually get mapped to the revision, which again is your code plus any configuration that you have? And in this case, there's just one revision, but you could have multiple ones for doing things like canary or traffic splitting. So I could say I want 50% of my traffic to go to this revision and 50% to go to the other. And I'll show that in a demo in a second. All right. So let me actually talk through the demo before I do it. So this should be familiar. So now we've got a route, and I'm going to have 100% of my traffic going to this particular revision. So this is, in this case, my blue version of my app, v1. 100% of my traffic. This is my first deploy. All is good. But now I have a new version. I have a green version that I wanted to introduce, and I want to sort of gradually put traffic on green until I verify that it's good, and then move all the traffic over. So I'll introduce a new revision, which has a new version of the app, v2 of the app, and also has new configuration. The background is green, for example. And I just want to deploy it, but I don't want to route any traffic to it yet. So in the YAML, which I'll show you, you can say, I want 100% of my traffic to go to the blue version, 0% to go to the green version, but I want to be able to access the green version so that I can verify that it looks good before I move any traffic over. Once I've verified, either manually or maybe through some set of Selenium scripts or whatever, that my app is now working, I can run a canary and actually start to give some of that traffic to users. So in this case, say 2% of the traffic I want to go to the green version, the green revision, and then 98% blue. If it all checks out, no huge errors, then let's swap everything over to the green version. And you'll see here there's a v1 down there. So you can actually name the old version so that I could still go to it, just in case I need to have it up for some reason, for historical reasons, or in case I need to quickly roll back for whatever. I can actually keep it up with a named URL so that I can still have it accessible. So let's actually implement that. All right. So I'm going to do a slightly different version of the app. All right. So that we're going to go away from our 3D rendering one into a pre-built one that all it does is has a blue box and the version of the app in it. A couple of things. So configuration, like I said, is metadata about the application. So this would be things like what is the API endpoint? What's the URL to hit the staging API versus the production API? Right, things that are different with a different deployment of your application. So in this case, it's injecting it as an environment variable called tversion and value blue. So this is what gets deployed in the as an environment variable with your code. It's going to be as a container, of course, and here is the published container. So that, again, that's the configuration. That's just the code plus configuration. There's no actual way to handle the request yet. So for that, we're going to have a second thing called a route. And we name the route. So this actually, again, this will specify what is the URL that we'll access through. We'll name the revision. And the reason we name the revision is so we can set properties to it, including we could add a URL, which I'll do in the next step, or set a percentage of traffic. So let me do this. kubectl, apply, stage 1. And all right, it's going to create a route, and let me get the URL for that. kubectl describe route blue-green. And somewhere in here we go, blue-green default. So let's go load that up and see what that looks like. All right, so app v1, blue. Again, we're going from blue, v1, to green, v2. But it created that URL for us automatically. And if I go over here, I should have done this earlier, you can see all the pods that are running. And in fact, let's go back to, so you will notice that there's no Howdy 3D, that was our 3D rendering. There's no pods, active pods for that. It's because it went to sleep. So now if I go back and I make a request, we should see it wake up, and yeah, there it is, Howdy 3D. So you can see, let me take the font down a little bit. You can see it actually started spinning up that pod to serve my request. It takes a bit. Cold start is something that's being worked on, but it's also just takes a minute to do some 3D rendering. But you can see this pod had gone to sleep. And so that's sort of a new behavior introduced with Knative that Kubernetes doesn't necessarily do. All right, so let's go back. We want to upgrade our app from v1 to v2. So we're going to do a couple of things. We're going to introduce a new configuration, which actually has a new version of the app. So this is actually pointing to a different version of our code. But it's also introducing new configuration data. So it's changing the environment variable from from blue to green. And we're going to keep the same route name because we're not actually creating a new API endpoint. We want to keep the same endpoint. We just want to change the version underneath. So we'll keep blue green. But now we're going to introduce a couple of metadata about the revisions. So we're going to keep actually traffic at 100% for blue-green 001, which is the blue version. But we're going to give a name to 002 and give it no traffic. So what that will do, kubectl, apply, stage 2. All right, so if we go back here to my app and I refresh it, this should be unchanged. But because we gave v2 a name in the revision, in the URL, you may not be able to see it on the screen, but I'm going to prepend the whole URL with v2 dot. And if I log this, so now I can actually access v2 of my app. v1 is unchanged. This is my sort of production server. Everything's good. I don't want to change any behavior yet, but I want to be able to verify, again, through automated scripts or manually, that v2 is up and that it works and everything is good. And I can do that through that URL. So let's say that's all good. Now we want to actually start putting some real users and real production traffic on v2. So here is the YAML to do that. So in this case, we're not creating a new configuration. We're not doing a new revision. We have both versions already deployed. We just want to change the routing logic. So a request comes in. How does it decide where to go? That's the only thing we're changing. So we're just going to say keep the same revision name, give it 50% of the traffic to go to blue, and then 50% to go to green. So let's do that. kubectl, apply, stage 3. And now, if all goes well, this is v2. Let me go to this one. All right, so this should roughly half of the time should come back blue, and half of the time should come back green. So let's refresh. So it's green. Refresh it. Come on, Wi-Fi. Come on, Wi-Fi. Yeah. All right, green, roughly half of the time. There we go. Blue, green, blue. You believe me, right? I can stop clicking around. All right, so let's say we did some testing and we looked at the logs. We haven't introduced any new errors in the system. Let's go ahead and move all the traffic over to v1. So here's our other YAML file. Similarly, we're just changing the route. We're not changing the deployed configurations or revisions. We're just going to take 0 traffic to v1 and 100% of traffic to v2. And we've actually now named v1. And the reason we do that is we can actually go back and check out v1 if we want to. So kubectl, apply, stage 4. All right, so if I refresh this, it should all be green, v2. We'll do it a few times. Come on. Come on. All right, no blue in sight. But if we want to access the blue version, again, we can just prepend v1 because that's the name we gave it. And it should give us all blue versions. Yep, and I can refresh, 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 because it's hard-coded to give 100% or to always return that version. All right, so that's red, blue, green. That's what that looks like in Knative. The next demo I'll do, yes, I think we have enough time, do some autoscaling, show you some of the characteristics. You got a hint of that with these pods, right? So you can see that the pods that was running to do the 3D rendering, the Howdy 3D, has already gone back to sleep. And we have only 2 pods active, one for blue-green 001, which is blue, and 002, which is green. That's because I was recently giving traffic to them. But if we check back in a second, those probably will both go to sleep and scale down to 0. And you can obviously tweak the scaling characteristics there. So let's take a little scaling demo. All right. You'll forgive me for copying some of these ahead of time. But let's look at the Autoscale service. So this is a pre-built container. And all it does is you give it some parameters, and it calculates the highest prime number under some limit. You give it some amount of RAM to sort of fake allocate. We're just simulating workload. So let me deploy this. kubectl apply autoscale service. And this is, so this is it. There's nothing else in this document. So I don't, just FYI, because I am declaring a service, it will automatically create a revision and a route for me. So I only did it in the last case because I specifically kind of wanted to customize the behavior. But by default, it'll create those named routes for you, put all 100% of the traffic. So you don't have to do that. All right, so now that we have this, hopefully this has deployed. Let me load it up. Nope. All right. So let me zoom in. So I can give it this, in the URL, I can give it this thing called bloat. So it allocated 5 megabytes of memory, calculated the highest prime less than 10,000, and then slept for 100 milliseconds. So I can change those parameters. So if I want to actually, I want it to allocate 15 megs of RAM and sleep for 250, I can just do that in the query string. And so yeah, so it allocated 15 megs of memory and then slept for 250 milliseconds. So that's what our function is doing, and now we're going to load test it. So it's basically to simulate something that's doing something useful and interesting under load. Let me run this. All right, so request stats. Now if we pop over here, you will see, so you've already seen the blue-green, I mean, all those pods have gone to sleep. And so now we have one pod to handle this traffic. But as our requests come in, and you can see we've got, it's 300 concurrent requests, 999 QPS. We should, why aren't you scaling? All right, fine. You want to do this? Our, I'm going to say concurrency is 900. And let's see if then prime, let's say bloat 15. Try not scale on me. All right, hopefully we should see some more. My code is too efficient. There we go. So now you can see it actually, one pod wasn't able to handle all those requests concurrently, so it's going to spin up additional pods to handle the additional traffic. And in this case, I think 3 is probably enough to handle it. Oh, it's 4. Okay, so it's spilling over to 4. Now, if you want to actually look at sort of the scaling characteristics of like how many pods it thinks it has and how many it needs, by default, there's some built-in monitoring dashboards. So let me pull this up. This is a built-in Grafana one. I'll open it here. And all right, port 3000. Nope. If I could type. All right, that should just take a second to load. I want to know how many do we have now? Oh, down to 2. Oh, am I done here? Okay, so if we look at this report, hopefully we've had enough data on that just to get a sense of. So here's scaling characteristics. Come on. I'm going to blame the Wi-Fi. It certainly is not anything I did. It should return. I see a little spinning thing here. So I think it probably just hasn't run long enough. Oh, maybe I'm on the wrong revision. Let's try this. Oh, I guess here we go, spinning. Come on. Come on. But if this fails, I put a screenshot of this in the slide just in case. But it has metrics like how many pods it thinks it would need to handle the traffic, how many it has. Oh, here we go. Here's a little bit of data is coming in now. So things like no data point. Okay, waiting on that one. But CPU usage, so you can track how efficient your code is, how much memory is it using, and so forth, and you can change those characteristics. And here we go. Here's pod counts over time. So you can see it started at 1 until I got annoyed and I cranked it up, and then now went up to 7, 9. Are we at 9? Yeah, oh, we're about active 4. Anyway, so this is automatically, these metrics are automatically captured for you. What else do I want to show on this? Scaling, debugging. If you've used Grafana as a tool, like these should be fairly familiar. HTTP requests. You can just see how many requests have come in. Success rate, oh, not 100. Can't even blame the Wi-Fi for that. But you also see response time, and it gives you like percentiles. So I don't know if you can read that on the screen, but in the 95th percentile, 10 seconds, geez. But over 50% under 3 seconds, and so on. 50%, oh, here you go. Yep. Anyway, I won't just read the graph out loud to you. You can play with it. So that was auto-scaling. Here is my screenshot in case the metrics dashboard didn't load. And we don't have time to get into these, so I talked mostly about serving there in terms of like blue, green, and canary and all that. But there's also build. So the idea behind Knative build, again, is you take your source code and create a deployable image from it. And it works essentially as a series of container steps. So each of those containers can do different things. So you could have a container that does the build, so it takes your source code and does all the compiling, and it'll hand it off to another container that maybe runs the tests or injects some other library. And then maybe a final container that optimizes your deploy and is maybe super lightweight and has none of the build tools on the other containers. And it looks something like this, right? So first you compile, and then you maybe build a Docker image out of it, and maybe the next one is deploy to Docker or whatever. So the idea is, as the URL, or as your code changes in GitHub, it kicks off these series of containers to do a build. And so here is another example. You could take your function, again, if you want to have an invoker that wraps it in a web framework, you just write your code, container can wrap an invoker around it, and then take that app, push it to a registry as a container, and then deploy it. And because it all happens on the cluster, I'm kind of speeding up here, because it all happens on the cluster, you don't need Docker. So again, it makes for a nice developer experience. Write code, push to Git, for example, and be done. Eventing, this actually has changed, I think, a little bit literally yesterday, and I have not had a chance to update it. So things are new and exciting in Knative. They're moving quickly. But fundamentally, these are some of the objects involved in binding events to your code. I mentioned this earlier. I don't know how to say this, KNCTL. So one of the guys from Pivotal wrote this utility so you don't have to muck with all those YAML files necessarily. So this is pretty cool. Like it will tag the previous revision automatically, and tag the new one. You can just do it in one command line. So knctl deploy service, give it your image, your Docker image, and then some environment variables there, and it does a lot of that YAML stuff for you. Again, it's not an official CLI, but it seems to work pretty well. And as I just mentioned, yesterday Knative 0.2 came out. It's early days. Some things around looser coupling, so you can use just build or just serve without having to bring the others in. Pluggable subsystem, so it uses Istio at the bottom. This is an effort to make that a little more pluggable, so if you have some other service mesh framework or something that you want. Improved cold starts, working on. We added some tweaking around auto-scaling characteristics, so how long before you scale to 0, how long before you scale up. And then I don't think it quite made it in 0.2, but I think the pull request is in to do, like you could have a minimum instances, right? So if you don't want it to go to sleep at all, you actually want to keep some 1 or 2 or 3 pods available. That's coming. All right, so that is all I have. Everything pretty much cloud.google.com/serverless, or Knative is on GitHub at github.com/Knative. There's a Slack channel. And then if you want to do containers on Google Cloud Functions, which I showed in the 3D rendering right away, there's a sign up for the alpha, which is g.co/serverless containers. And all right, again, if you want to follow me on Twitter, ask me any questions there, I'm at Bret MCG. Thank you very much.